The universe is going to end. That part is not in dispute. What is in dispute is how. There are three ways it can happen, and they are not variations on a theme. They are completely different endings. One is cold, one is violent, one is a reversal. And which one you get depends on a single number that we have been measuring for 30 years and still cannot agree on. That number describes dark energy. 68% of everything there is, and we have no idea what it actually is. But we do not need to know what it is to know what it does. We only need one property. In the next few minutes, I am going to show you the endings exactly of what each one requires to be true and what the latest data actually says. Not what it might say, what it says. The number is called W. It is the ratio between dark energy's pressure and its density, and it decides everything. If W is exactly -1, dark energy is a constant. It does not dilute as the universe expands. There is the same amount in every cubic meter of space forever. If W is greater than -1, dark energy weakens over time. It thins out. Its grip loosens. And if W is less than -1, what physicists call phantom dark energy gets stronger. Not stays the same, stronger. Each of those three cases ends the universe differently. Start with W equals -1 exactly. This is the standard model. Dark energy is a constant. Expansion keeps accelerating, and nothing ever reverses it. Galaxies outside our local group cross the horizon and disappear. Not destroyed, just permanently unreachable. Star formation runs out of gas. The last stars burn out. What is left is black holes, and black holes evaporate. Slowly. Over something like 10 to the 100 years. And when the last one goes, there is nothing left that can do anything. No gradients, no temperature difference, nothing to extract work from. That is heat death. It is not an explosion. It is a universe that runs out of the ability to have events. Now, make W less than -1. Phantom dark energy. Now, the density of dark energy grows as space expands, which means expansion feeds itself. It does not just accelerate, the acceleration accelerates. First, galaxy clusters are pulled apart, then galaxies, then solar systems. The Earth stops orbiting the Sun, not because either one is destroyed, but because the space between them is growing faster than gravity can close it. Then planets. Then, in the final fraction of a second, atoms. Every bound structure in the universe torn apart in order of size. Largest first, smallest last. That is the Big Rip. And unlike heat death, it has a date. And the third. Make W greater than -1 and keep going. Dark energy weakens, keeps weakening, crosses zero, goes negative. Now it is not pushing anymore. It is pulling. Expansion slows, stops, and reverses. Everything that has been flying apart for 100 billion years starts falling back together. Galaxies collide. The background radiation of the universe blue shifts, and the night sky gets brighter, then hotter, then lethal. That is the Big Crunch. And it is the only one of the three that is not necessarily an ending. It might be a bounce. Three endings, three completely different values of one number. Which means this is not philosophy, it is measurable. You measure how fast the universe was expanding at different points in its history. You compare those speeds, and W falls out of the comparison. which is exactly what an instrument on a mountain in Arizona has been doing since 2021. 5,000 robotic fiber optic positioners taking the spectra of millions of galaxies. And in 2025, it published what it found. And the number was not -1. DESI, the Dark Energy Spectroscopic Instrument. In March 2025, it released its second dataset. Combined with the cosmic microwave background and with supernova measurements, the data preferred a dark energy that changes over time over one that stays constant. The statistical strength, depending on which supernova catalog you combine it with, ran between 2.8 and 4.2 sigma. And the direction matters more than the strength. The best fit had W greater than -1 today, and more negative the further back you look. In plain language, dark energy appears to have been stronger in the past and to be weakening now. So run that back through the three endings. If dark energy is weakening, it is not phantom. W is not less than -1, which means the Big Rip. The most spectacular of the three, the one that every documentary opens with, is the ending. The current data argues against. What is left is heat death if the weakening levels off, or a big crunch if it does not level off and keeps going past zero. The most violent ending is the least supported. The two still standing are the slow one and the one that turns around. Now the part most videos leave out. This is not a discovery. In physics, the threshold for that is 5 sigma, and nothing here has reached it. 3 sigma results fail all the time, and the result is not stable across choices. Swap in a different set of low redshift measurements, and the preference for evolving dark energy drops below 2 sigma, which is consistent with a plain cosmological constant. Independent groups have rerun it. Some find the signal holds. Some find it depends on which supernova catalog you trust. That is not a scandal. That is what a real result looks like at this stage. So the honest answer to which ending we are heading for is this. The Big Rip is disfavored. Heat death remains the default. A big crunch is possible, and it was not seriously on the table 5 years ago. And the number that decides it is currently moving, not settled, moving. For most of human history, the end of the universe was a question for theology. It is now a question of measurement. We do not have the answer yet, but for the first time, we have built the instrument that will produce it. And most of us will still be here when it does.